In this video, we're going to show how to use the EM extract feature in Microwave Office to set up an EM simulation from the schematic. And our structure that we're going to be simulating is going to be a microstrip open circuited stub resonator. So all I've done is start a new project and let's build our circuit. So on the left, we look for circuit schematics, right click, and then click on new schematics. And we can just call this M stub resonator. And here's our blank schematic. We go down here to the bottom left, click on schematics, and let's start building our line. So first let's click here on Microstrip, click on lines, and then look for M line, drag that over. Click it, hit Control C, Control V to copy and paste. Those are two lines. Let's see, is there anything else in here? I think we're good. Let's click up here on junctions, and we want an T junction, MT, so drag that over here. Click it, Control R to rotate, and then rotate it with your mouse. And connect it up. Let's go back up. Let's go back to lines. I think they have an, here it is, open microstrip line with end effect. Bring that over, M left. Click it, Control R to rotate, rotate with the mouse, and then snap it into place. Let's add ports to this. So here's port 1. Up here, click another port, bring it down. I'm going to rotate it by hitting Control R, and then move this. So this is the basic structure. We haven't put the physical dimensions in yet. We'll do that in a second. Let's go back up here to substrates, and we want to click on M sub, microstrip substrate definition, and bring that over. Okay, let's start putting in our geometry here and our substrate parameters. So for our substrate, we're going to do epsilon r, dielectric constant is 1.96. Now, before we put in the geometry, we actually want to set the units. So let's do that now. Go to Options, Project Options, Global Units. Frequency will be gigahertz. We'll do our length will be in inches. I think we can leave all this other stuff the same. Okay. While we're at it, let's change our frequency. We'll go from 1 gigahertz to 2 with steps of 0.001. Hit apply. So that will be the frequency range that we're going to simulate. So we just set that up now. Okay. What I'm going to do, because a lot of these, or all these structures have the same width, I'm going to go up here to equation, start a variable, just to make it easy. W1. And for this width, it's going to be 0.166. This will give us 50 ohms. I've already calculated what the width should be, so that the lines are 50 ohms given our substrate that we still need to put in these parameters. But let's just change the widths real quick. So W1, W1, W1. All the widths are just going to be W1. Make life super simple. Okay, and let's just put the length in. So just copied and pasted it. So these lengths here we're going to make, well, these are all L1. This one's going to be L1. So we made these two lengths L1. And the value for L1 we're going to say is 0.4 inches. So 0.4. And this guy, the stub itself, is going to be L2. And so that it resonates at around 1.5 gigs, we're going to make this length 1.4 inches. It should be L2. Notice real quick that this is highlighted in red, which indicates, hey, there is no L2 defined, and that's this. Once I define L2, that red will go away, watch. And it goes away. Okay, so that's set up. We still got to go up here to the substrate. So the height of the substrate thickness is 0.05 inches. The thickness of the copper is going to be 0.000138. I think that's 1 ounce copper. Rho, because it's copper, is going to be 0.689. We actually calculated rho in an earlier video where we were discussing the transmission line tool. The loss tangent is 0.000138. Then I change this epsilon to that 1.96. Okay, so that's everything. Let's actually simulate this and see what response we get. Let's go here to project. I'm going to hit save and just let it, I'll just do example. Save right over what we had. Good. Let's look at the graph. So we go to the left and we click on new graph, rectangular. Here's our graph. We're going to do add new measurement, S21, insertion loss. And then I did that quickly. Let me go back. I clicked on magnitude in dB. We want to plot S21 magnitude in dB. And then to actually plot it, we go over here to analyze. And there's our response. So this is no EM simulation at all. It's just using these closed form models. So now we actually want to simulate this in an EM simulator like Axiom. Okay. For comparison purposes, we're going to just start a new schematic. You don't have to do it on 2 schematics, but I want to compare what we got using the closed form models to the electromagnetic full wave simulation. So to do that, I shouldn't say full wave. I'm not sure if it's full wave. It's kind of 2.5D simulator. Let's click on circuit schematics. Actually, can we just duplicate? Yeah, okay, let's do that. So here's M-stub resonator. Let's just duplicate that schematic. And we'll rename it EM so that it will remind us that this schematic is going to be linked to the EM simulator. Okay, so let's leave everything else the same. Now, how do you actually generate an EM simulation from the schematic? The nice thing here is they have scripts. So let's go to scripts and go down to EM and then click create stack up. Click on that. And wait a second. Hopefully something happened. Oh, okay. We can leave all this, so it's going to select a substrate. This is this one substrate we have. We can leave all this stuff the same, hit OK, and then it automatically puts these new elements in the schematic. So the first one we want to look up is stack up. Now, this script thing makes it easy, but the stack up is actually, and the extract block are both in, you can find them in the elements. So the stack up is actually substrates, and then there's a stack up, multi-layer substrate definition, and then the extract block. Sometimes I have a more difficult time finding. Let's see. Oh no, I remember. It's simulation control. Where is that at? There it is. And there's the extract block. So you can move these from the elements. You don't have to go through the script, but the script is nice because it just creates them for you. Okay, so let's click. What the stack up does, we'll double click on that, is based on the substrate that we defined, it actually creates the substrate definition for that. So you can see the epsilon r is already put in here, the loss tangent, it's copper. It defines our dielectric layers, materials, and all the rest of it. There's one thing we'll need to change in a second, but let's just leave everything how it is as by default. Now the stack up is basically creating the substrate definition for the EM simulation. So if we change the stack up, it won't change anything in the schematic. It will change what's going on in the EM simulation. Now this extract block, this is the link that goes from the schematic to the EM simulation. Now the simulator is Axiom. You can choose the others, some other simulators. We're going to stick with Axiom. And the X cell size and the Y cell size are things you might want to change. So we're going to change this to 0.2 inches. And basic rule of thumb is the smaller the cell size, the longer your simulation is going to take, and the larger the cells, but the more accurate it will be. So smaller the cell size, longer the simulation, and more accurate. Larger the cell size, the simulation might run faster, but it might be a little less accurate. That's a general rule of thumb. Okay, we've set that up. Now, next thing to do is I'm going to click on all the elements in this schematic that I actually want to simulate in the EM simulator. So I'm going to click on this, and I'm hitting Shift and then clicking on the other elements to kind of highlight them all. And then somewhere like here, I right click and hit Properties, go up here to Model Options and hit Enable. So this will enable the EM extraction. If you have multiple EM extraction definitions here, you can have different groups. We just have one. This is a basic case, so just click Enable. Okay, now when I click on this, you see how all these elements become red? That means that they're enabled to be extracted for an EM simulation. If I say take this one off, so I go to Properties and don't enable it, now when I click on here, it's only going to create an EM simulation from these. So you want to highlight everything that you want this extract block to create an EM simulation for. So there. Okay, so now we click on this and we hit, so I right click on the extraction block and click Add Extraction. It does its magic. Now this doesn't look so good, but we'll fix that in a second. If we go here to EM structures, it created an EM structure, which is presented here. This doesn't look like what we want. For example, there's only one port I see. Maybe there's two. They're overlapping. There's something wrong. So what that something is the layout is wrong. So let's go back to our schematic. In fact, I'm going to close this off. This graph, I guess we can keep open. We're going to close this one off. Let's go to View Layout. Now here's the layout. These are the different components of the circuit, and they're kind of all jumbled all over the place. We want to snap these things together. You can do that manually, like I'm doing here, or the easiest way is to go Edit, Select All, Snap Together. So you got to snap them together first. Now we go back to here, and now when I do my add extraction, everything looks nice. So it's from the layout is how you actually lay the circuit out. You don't lay it out in the EM simulator. You lay it out in this layout tab. Okay, there's a couple other things that we need to think about. So let's click on this, right click, so we're up here in the kind of double click on the EM structure. If you right click, go highlight it, right click and do shape properties, it says missing material. It doesn't know that it's copper, so that's a problem. It's one thing that can be slightly annoying with this script. So we have to set it to be copper. Now you can right click, shape properties, and just set the material here. Or if we go back to our schematic and go to the stack up, double click on that. Let's see, there's copper there. Here. So there's drawing layer, look for copper, EM layer 2, and make that material copper. Let's see if that fixed it. So unfortunately, you might have to keep right clicking on this and doing add extraction. It won't automatically add an extraction for each change you make. So add extraction. Let's go back to here, and did that change it? And it's changed to copper. Okay, so there's that. And now something that you might want to do, that I do before I simulate, is let's go back to here to our EM simulation. It's good to see your 2D mesh. So let's go up here to the upper right and click Show 2D Mesh. And this looks good. Now, how is this mesh defined? The mesh is defined here in the stack up option when I said 0.2. If I change that to 0.001, say, let's just leave it. So let's say the X cell size is 0.001 and the Y cell is 0.2. Right click, add extraction to update the EM simulator. Let's go back to the EM simulator. And then click again on to show the mesh, and now it's going to be calculating this mesh. Now you can see this mesh. Now this thing is just, the mesh is extremely dense, and just from experience, this thing is going to take forever to simulate. The results might be perhaps more accurate than a larger mesh, but it's going to just take orders of magnitude longer to simulate. So that's not good. So that's why I chose 0.2, because 0.2 seems like a good compromise between accuracy and simulation time. So now let's go back to add extraction, back to here, recalculate the 2D mesh, and that looks a lot better. Okay, so I haven't simulated it yet. I think we are ready to simulate. So before I simulate, I'm going to go back here to the graph, and I'm just going to delete measurement, and let's just add new measurements and see what's going on. So we want to do S21. I want to do M stub resonator, S21 magnitude in dB, and hit apply. This is what we've already simulated. This is the closed form microstrip models. And now I want to add new measurement and do M stub resonator EM and hit apply. And that we haven't simulated yet, the EM simulation, so it's not showing up yet. But it's always good to start to have your measurement set up before you click analyze. And I think we are ready, so we can just, even from the schematic window, hit analyze, and it might take a second or two, or a minute or two. Let's see it. So it's just going to be doing its thing, so all we got to do is wait for it. See, I have my keyboard here. I might play a song while we're waiting. Okay, did it do its thing? Nope, it is still simulating. Oh no, it worked. Okay, you can close it. And there it is. So in the pink curve is the EM simulation, and the blue curve is the closed form microstrip model, and you can see they're very similar. Okay, one other thing I want to show before we close this video. Now watch this. Let's say I go, I want to change L1 to 0.2, not 0.4, 0.2. And I'm going to, add the extraction. When I click here, it is messed up. Now, why is it messed up? It's messed up because you can see it even more clear if I click on View Layout. It hasn't snapped. It's not automatically snapping. So how can we fix this problem? Because every time you change a dimension on the schematic, we don't want to have to re-snap everything together. It can get really annoying fast. So the way you can fix this is if you go to Tools, no, not Tools, Options, Layout Options, and I'm going to, right here, Layout Cell Snap Options, change that from manual to auto snap on parameter changes. Now when I hit OK, it's probably going to give an error, and I still haven't figured out, but it's going to say something about this database unit size, I believe. And there it goes. Database unit is not greater than or equal to 1. And so you're kind of stuck. You can't hit cancel because then you just canceled what you just did. So this is maybe a bug in the program. I'm not sure. So to fix this, we'll just actually have to set this grid spacing. Let's go to 0.0001 maybe. 1e-5 for the database. And just let it be. We might have to do one more snap on here. So edit, snap together. Okay. Go back to the extraction. Oops, we have to do add extraction from this menu first. Add extraction, and then if we go back to our EM simulation, there it's nice looking. It's perfect. Now let's try to change this from 0.2 to 0.4. Right click again on add extraction, and now it's fine. So now you can actually change the parameters on the schematic and have the EM simulator change accordingly without some funny shapes being isolated just because you changed a parameter. And that's again due to the fact that in the layout you have to have these shapes automatically snap together. Alright, so that is basically, we have covered the basics of how to use the EM extract feature in Microwave Office to set up an EM simulation from the schematic.